Hey guys, what's up? I hope you are doing fine and hopefully have no problem related to COVID-19 and all. What I'm about to do here is the next topic from solution, and today's topic is going to be describing you a solution where solid is dissolved in a liquid. So basically I'm talking about liquid solution, right? So 12th class has two types of liquid solution to study. One is solid in liquid and other is gaseous in liquid. Gaseous in liquid is about Henry's law and all, but solid in liquid is going to be a small topic. So that topic is is the primary concern right now. So let's do that. So I'm talking about solid in liquid, right? So I'm talking about solid in liquid. That's our topic is solid in liquid. Now the question is, if you have watched, the very previous lecture where I have described all the 9 types of solution, right? So because we are adding solid in liquid, so the physical state of the solution will be a liquid. So we can write it like liquid solution, liquid solution. If you remember, I have described you that the physical state of solution depends on the nature of the solvent, on the physical state of the solvent. So because there the solvent is a liquid, therefore the solution physical state will remain liquid, right? And if you want to have some example, there you have the example salt or maybe sugar. That's very common example. Sugar in water. Sugar in water, this is a very common example for explaining this kind of topic. Now, the question is, a solid in a liquid is called a liquid solution. Sugar with water is an example. What are the factors on which solubility of solid in a liquid depends? So that's very important, and that's something you might be aware a little bit about. But something you are missing, I'm going to explain you right now. So factors on which, so the next thing I'm about to describe you is factors. Factors on which the solubility depends. Solubility depends. So on a broader scale, there are actually two factors that describe the solubility of solid in liquid, right? And third one, which doesn't play an important role, but it's still, it's something you have to be aware of. So what are the 3 factors I'm talking? The first one is nature of solute plus solvent. Nature of solute plus solvent, right? Solvent. So this is again something important. You do remember that a statement from even 11th class, that like dissolves like. Like dissolves like. What that means? You have to remember that solubility of solid in liquid depends on like dissolves like. So what this statement is, I'm about to explain it. Like dissolves like. Like dissolves like. So what it means here is that polar solute dissolves a polar solvent, right? A polar solvent dissolves a polar solute, and a non-polar solvent dissolves a non-polar solute. So what that means? It has 2 types. First, like I said, polar solute dissolves in polar solvent. I'm going to give you some example. Polar solvent, right? Polar solvent. And what is the example here? I give you a simple example, which is nothing but HCl. So hydrochloric acid. And why this is, why this is a polar solute? HCl. If you remember, the dipole moment in this case is towards the chlorine. Why? Because chlorine has a partial negative and hydrogen develops a partial positive. So the electron appears to be shifting towards chlorine. So that's why it is a polar molecule. So this is your polar molecule, right? And let's talk about the very common solvent or universal solvent, we can say water, right? So we have water here. We have water here as a solvent, and it has 2 lone pair, as you probably know that. So what is happening here is that it has also dipole. It has also dipole here, partial positive on both hydrogen, and similarly partial negative on oxygen. So due to their partial negative and positive, an interaction develops right here, and this interaction is nothing but a van der Waals force of attraction. So because both of these molecules are polar, this one is also polar, this one is also polar, right? And if you want to know where is the dipole moment is in this direction. there is not enough space, and both of these lone pair dipole is again, upway. So this is also polar molecule, this is also polar molecule, and that's why, they can form a solution, right? If either of them were polar and the next one was non-polar, it's never going to form a solution. Or if you want to make a solution, you have to spend some extra energy, and even then the solubility will remain very, very small, right? They dissolve, but in a very small amount. For example, oxygen in water. Oxygen is a non-polar substance, water is a polar, and that's why the solubility is very, very small, almost like negligible for us. But for animals, for aquatic animals, it's enough to survive, right? I'm coming to that, but let's take the next example. The next one is, non-polar dissolves in non-polar solute. Non-polar solute dissolves in non-polar solvent. Non-polar solvent. What example, if you remember? There's so many examples, and that example is here. The example is any organic solvent like benzene, maybe. It's the benzene here, and benzene with naphthalene, I can consider naphthalene. So this is a case where a non-polar substance is dissolving in non-polar. Let's take the next one. Which is a polar, a non-polar solute plus a polar solvent. What happened in this case? No solubility, or a very small, or very little solubility, right? And the example is, I just told you just a short while ago, oxygen plus water. So this is an example where the solubility of oxygen is very, very small in water. So solubility of a solute, solubility of solid in liquid depends on the first factor, nature of solute, and then it's the temperature, which I am about to explain you, right? Now let's talk about the second factor, which is the temperature, right? This is very important. So the second topic we have, the second factor we have is temperature, right? So temperature is directly proportional to solubility of solid in liquid. Solubility of solid in liquid. And the very common example you do remember, and as well me here, is the sugar in water. To make thick sugar syrup. Right? Let me repeat back something. If you want to dissolve sugar in water, it's not easy to dissolve. So what you do, you start heating water, and once you provide, that thermal energy into water, the bond dissociation become quite an easy, and therefore the sugar is easy to dissolve in water. So hot water is, something you prefer to dissolve sugar into, right? And the only reason is that once you increase the temperature and the thermal energy is utilized in breaking the bond between both, and that's why the solubility become easier. So temperature, on increasing the temperature, the solubility of solid in a liquid increases. Now let's talk about the third one, right? The third one is pressure. Actually, pressure has no effect on the solubility. So no effect on the solubility. The reason is that both solid and liquid are incompressible. Right? What that means? Pressure has no effect at all. It does not, increase or decrease the solubility of solid in a liquid. It's because both solid and liquid, they both are not compressible. So increasing the pressure over solid and liquid does not change the volume, and that's why pressure has no role on the solubility of solid in a liquid. So these are actually three factors. Let me remind you, give you a recap. We are talking about liquid solution, where solid is solute and liquid is a solvent. It depends on three factors. The first one is nature of solute, and what was important here? Like dissolves like. to have better solubility, they both must be polar or they both must be non-polar. If one is polar and other is non-polar, either they are insoluble or the solution will not be formed, or there will be a very, very small, very, very little solubility of the solute. The second is very important, temperature. Temperature is directly proportional to solubility of solid in liquid. What that means? If you increase the temperature, definitely the solubility of solid will increase. The very simple example here is that, in order to dissolve sugar in water, you need to heat the water. Why? Because the heat energy you are providing is utilized in breaking the forces of attraction between the molecule, and that's why they start coming closer, and this solution become possible, to be made here. And the next one is pressure. I told you that pressure has no effect at all on the solubility. It does not increase, does not decrease it. Why? Because both liquid and solid, we have both two components, solid and liquid, they both are incompressible, so pressure does not play any significant role in the solubility. So this is something I wanted to do in this lecture. I'll say thanks for watching, take care, and don't forget to come back for the next lecture, which is going to be about gases in liquid, and there you will have Henry's law coming up, which is very, very important, right? So thanks for watching.